Okay friends, welcome back. We just discussed measures of variability in the last class. We have discussed measure of central tendency also. Now we are going to discuss something very new, very quite useful. Okay, this is called mean centered data and standardized data. Now for that I will be just taking you through the slides and then we will move on paper board. We will write through board. Okay. So what is the mean centered data? Every data is subtracted by the mean average. Okay, every data is subtracted by the mean, or every data actually becomes the average deviation, which we discussed in the measure of variability and measure of central tendency. Every data itself becomes the average deviation. That is the mean centered data. What are the advantages of that? We will talk about it. And there is something called standardized data. Standardized data is a ratio of average deviation divided by the standard deviation of the data. Okay, let us go ahead and I will show you in calculation, do not worry. Okay, so as I told you, shift data to mean, the mean that is 0, and shift data in scale so that the mean of the data is 0 and standard deviation is 1, and we will talk about that right now also. Okay, do not worry. So please see, this is mathematics. Okay, mean centered data is equal to original data minus mean, standardized data is equal to original data minus mean about standard deviation, or mean standard deviation, mean centered data divided by standard deviation. These are the formula in R command. We will learn that little bit. Now let me take you to the board before we start implementing this. Let us have the data 1, 2, 3, 4 and 5. So the average of this is 3. Okay. Now the mean centered data will be minus 2, minus 1, 0, 1 and 2. This is mean centered data. Now why is this required? Let me take a little step further and try to explain you the importance of dimensions in describing the data and the importance of taking ratios, like we took the ratio of coefficient of variability. Okay. Now suppose I have 100 meters, 200 meters, 300 meter, 400 meter and 500 meter. Now the average of this is 300 meters. Okay. Now what is the standard deviation? How will you get the standard deviation? Let us take this example right now. I will come to both examples right now. Please see. So minus 2 square is 4, minus 1 square is 1, 0 square is 0, then we have 1, then we have 4. So we have 10 by 5, 10 as the sum and divided by n, which is 5 here. So it is 2. So standard deviation, this is variance, this is standard deviation is root 2. Okay. On the same line, if you see, the standard deviation of this will be root 2 times 100. Okay. Now mind it, what is the coefficient of variation for both of them? For, let us say, this is data A and this is data B, coefficient B, this is for B, root 2 into 100 divided by 300, and coefficient for A is root 2 divided by 3. As you can see, both are root 2 by 3. So, standard deviation was here root 2. Let's give the unit, let's say kgs, everything is in kgs. So, average is 3 kg, standard deviation root 2 kg, and here the standard deviation for B is also root 2 to 100 into meters. Okay. But coefficient of variability for A and B are both similar. So, what actually it is means that this data is just multiplication or division of the original data, or there is a scalability of issue. Okay. Now, coming back, next page. So, as we talked, let us come to 1, 2, 3, 4, 5. We are standardizing data. So, the mean is minus 2, sorry, mean center data is minus 2, minus 1, 0, 1, 2. Our standard deviation is root 2. So, our mean center data becomes minus root 2, minus 1 by root 2, 0, 1 by root 2 and root 2. This is our Z score of if x is equal to this Z score of x or Z x, minus root 2, minus 1 by root 2, 1 by root 2 and root 2. Okay. So, now please understand, if we want to calculate standard deviation of this data, how we will calculate? Okay, let us try it. The standard deviation of this data is, the average is mean, the average is 0, minus root 2 square plus minus 1 by root 2 square plus 0 square plus 1 by root 2 square plus root 2 square divided by 5, and as you can see, the upper thing will become 2 plus 1 by 2 plus 0 plus 1 by 2 plus 2 plus divide by 5 is equal to 1. So, as we were telling, a standardized data has a standard deviation of 1 and mean as 0. Now, wow, again we will see this. What does it mean? Here again, if you see the standardized data, let us talk about 100 meter, 200 meter, 300 meter, 400, 500 meter. Okay. 100 meter, 200 meter, 300 meter, 400 meter, 500 meter. Okay. We know the average is 300 meter and the standard deviation is root 2 into 100 meters, and you will be not surprised, the standard notification will be minus root 2 minus 1 by root 2, 0, 1 by root 2 and root 2. So, now as the measure is just of scalability, when we come in a standardized form, the scalability actually reduces and then you get the data is just scaled. So, data A is B times 100. What was data A? 1, 2, 3, 4, 5. Obviously, there were units. So, 100 into some units. This was in kg and this was in meter. Okay. And B was 100, 200, 300, 400, 500. Now, the standard data is unitless. Z score is unitless. It is a ratio actually. This Z score is very important for further classes. We will be again and again studying this Z thing. So, please understand this thing. Again I will repeat. Z score is standardized data, which is nothing but mean standard data divided by the standard deviation. Okay. So, as sum of all mean standard data is 0, similarly sum of all standardized data is 0, that we will see, generally it happens. Okay. And these are the commands. Okay. So, now with this we have done more or less describing measures of variability and measures of central tendency. Now, when we describe Z score, we have combined both of them. We have by default, when we take a Z score, the mean becomes 0, the standard deviation become 1. That does not mean the mean and median become also 0. No, that does not happen. That happens only in symmetric data, as you will see in future classes. Okay. So, Z score is done. Now, we will be moving to a very important criteria of distribution, okay, frequency distribution. And before that, and in that, to explain that, we will use something called a Galton board, which is a foundation of a very important distribution called normal curve. Okay. So, we will see you in next class. Thank you.